problem with a drilling environment is you have a mechanical spinning mass that can be damaged with shock and vibration. The biggest gain for the solid state gyro is there's no moving parts. For me, the spear technology is huge in the industry. It's groundbreaking. It's going to completely transform in the future the way we drill wells.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about directional drilling, knowing how to accurately reach oil and gas miles below ground. Think about it. You're drilling thousands of feet. The drill is spinning. You're also often tilting the drill head at a slope. How do you know if the well is where it needs to be? I always figured there was some sort of sensor inside the drill, and a radar or sensor on the surface was picking up that beacon underground. My guess says that's not an option. Whatever you're doing to relay where the drill is located inside the drill and feeding that information back to the surface. It's on its own. The industry standard is called measurement while drilling. Often mistaken for magnetic while drilling, it uses a magnetometer and essentially functions like a compass to relay its direction. But what if something downhole affects the magnet? Remember Armageddon?
The gauges will not read. They're all peaked like we're plugged into some magnetic field.
Well, who on the spaceship wants to know why?
By all means.
The reason we were shooting for grid 8 is because thermographics indicated that grid 9 was compressed iron ferrite, which means you landed us on an iron plate.
My guess is even other well casings nearby can affect the accuracy of an MWD system. But MWDs are robust, they're solid state, and can withstand the toughest conditions Mother Earth can throw at them. Until now. My guest specializes in direction equipment based on gyroscopes. Gyro while drilling, GWD, uses a spinning mass and bases its direction on the spin of the Earth. Gyroscopes have been a little more temperamental. They can't handle the heat and vibrations of deep drilling conditions. The innovation, as you heard my guest describe, is a solid-state gyro, a gyroscope that doesn't need to spin. What you have now is the superior accuracy that can now go anywhere an MWD can go. My guest believes it will save countless hours and millions of dollars for drillers. Like my last oilfield guest, we also discussed the challenges of operating in an industry that has regular boom and bust cycles. How do you stay afloat when you know the industry is going to nearly put you out of business every 5 to 10 years? My guest says the key for them was to go back to the basics, to do what they did well, and that's gyro services. During the interview, we discussed what I call lazy MBA moves, management decisions that seem to be on autopilot. Anyone who's been to business school in the last 15 years has probably read Jim Collins's Good to Great about some general habits of successful companies. This focus on the core business principle that my guest is describing is called the hedgehog concept in that book. That was amusing to me for this guest because it reminded me of the most famous hedgehog out there. Yep, just like Sonic was most famous for his spinning moves in the games, my guest believes gyros are the future for the drilling industry. My guest today is Alan Bernard, Senior Vice President of Gyrodata, a technology and services company principally focused on drilling navigation equipment. Gyrodata has been around since the 80s. They demonstrated the first successful commercial GWD operation in 2001. Today they operate in over 50 countries and are based in Houston. Alan has been with the company his whole career. He got started in Aberdeen, Scotland, and has lived as far away as Kuala Lumpur. 2 years ago, they announced their solid-state gyro sensors, what they call SPEAR, that can make the entire trip with the drill. Gyrodata is also involved in the mining industry. They made global press for a certain rescue attempt in 2010. We'll get into that as well. I hope you enjoy my conversation with Alan Bernard. We're with Alan Bernard, Senior Vice President of Gyrodata. And Alan, in your business, the common technique for operators to know where they're drilling underground is what's called measurement while drilling, or MWD. You have a technology you call gyro while drilling, or GWD. So help us understand how GWD is different and what's happening there. Is there a gyroscope spinning while the drill bit is tearing through the earth? Explain it to us as if we were at dinner.
Well, I wouldn't be discussing this at dinner. I'd be having a glass of wine with you probably, but let me try my best to answer that pretty good question. MWD, as you mentioned, measurement while drilling, is sometimes incorrectly labeled as magnetic while drilling, and sometimes that is a mistake that people use in the industry. And the reason for that is MWD tools are measurement technologies using a magnetometer. An MWD tool is trying to determine a direction from the Earth's magnetic field. If you think of your little compass where it points at north, it's similar to that, where a magnetometer will sense the Earth's magnetic north pole, and then from that we'll determine an azimuth, just like you do with your compass. Obviously, those tools are affected by metal. If you have a compass and you bring a magnet near it or a piece of metal that's magnetized, it will sway the measurement. It will have an error on the measurement, and that's what we call magnetic interference. When you're in an oil well, there's a lot of metal around. Sometimes you've got magnetic rocks downhole, you've got magnetic anomalies if the sun has solar activities. Magnetic readings can be affected by interference from other steel. They're also not a constant measurement. The Earth's magnetic field is actually not a constant. And the magnetic North Pole, as we speak, is actually racing every year towards Siberia. It's not where you would think is at the spin axis of the world that you would think of as an Earth model that you would have on your desk. So why do we run a gyro? Why is it a gyro hole drilling system? Gyros are not affected by magnetic interference. They're not affected by nearby casing. And what a gyro is measuring is actually the Earth's rotation. The Earth rotates about its spin axis at a constant, which is obviously 15 degrees per hour at the equator. And gyros are not affected by steel or any magnetic interference. So gyros are more accurate than magnetometers. And it's more accurate because it's measuring a constant. Does that answer your question?
It absolutely does, Alan. And as someone who really doesn't know much about how you get where you need to go when you're drilling, in my imagination, I would be thinking, well, it's 2021. Why wouldn't you be able to scan the head of the drill bit and know precisely where it was? Is there just too much going on underground for you to pick up a signal like that? It seems like there's a lot of different ways that you guys could be going about this where you're determining direction based on what information you're getting down there.
Well, thankfully, GPS that we have on your Apple phones in your car, I wouldn't be where I am today. I'd be out of a job if those signals could actually penetrate the earth and go underground. This is the problem drillers have. They cannot use the accurate GPS signals below ground. So your drill bit, they've got to rely on navigational techniques pre-GPS. So back in the 1970s and 80s, before somebody invented GPS, airplanes flew all around the world. They didn't use a GPS. They used gyroscopic technology as a form of navigation. The same with ships' gyros. This technology has been around, I think, since the 19th century, gyroscopes, or the theory of gyros. That's why they need the gyros below ground.
Sure. I was thinking something more like the same technologies they use for seismic, where you can see what's going on underground.
That works for a short distance. You could call it like a radar, where you can seismically look 30 feet, 60 feet, 70 feet in front of you, and you'll see the differences in geological markers where you go from one formation to another. Some of these drilling BHAs are at 20,000 feet below the ground. Now you're talking about relative position from surface, not just 50, 60 feet in front of the bit. You need to know where you are relative to surface, not just relative from a few hundred feet. And that's why they can't use that type of seismic technology to determine exactly where they are underground.
And so Gyrodata recently announced a solid-state gyro. And since a gyroscope is by nature spinning, what does that mean? How is this a breakthrough?
Oh, this is absolutely huge for the industry, because all gyros up until, I think it was about 2 years ago when we launched our solid-state gyro, were based on a spinning mass, where just like you think from a high school or school where you see a gyro, it's a mechanical, it's spinning. The problem with that is in a drilling environment is you have a mechanical spinning mass that can be damaged with shock and vibration. It's got a relatively fragile universal joint, where if you've got the jarring down hole, or you've got a really rough drilling environment, which we typically have nowadays, where you have high levels of shock and vibration, the gyros will break. They'll actually be mechanically damaged, or they'll shift calibration. Historically, gyros were used in what we call benign environments, static environments. We ran them on wireline inside casing. We ran them on wireline inside drill strings. We ran them in surface holes where there's a GWD, where the formation is typically softer. Now, what solid state brings is the ability now to run a gyro very accurately in extreme shock and vibration environments. And that's allowed us now to run gyro hole drilling in all sections of the well, not just the surface sections where the formation is softer. So the biggest gain for the solid state gyro is there's no moving parts, and it will not be damaged by the shock and vibration downhole.
Were they having to switch to something else like MWD once they got deeper?
Yes, and that's where MWD is a solid state technology as well. It's solid state magnetometers. And then what they would do is they would run the MWD and then they would drop a gyro in the string, or they'd run a gyro in wireline, and then that would improve the accuracy as they drill. Now they can run the gyro real-time dynamically.
That's fantastic. Now, I have a little bit of experience in this, not necessarily with drilling. I was in the fracking sector. We did a lot of water treatment. And when I was working in the fracking sector, there were a lot of talks about zipper fracks where the operators had to drill a series of wells close to each other. I'd assume that even if one of these wells is off the mark, that could create trouble for the whole design.
Most definitely. You're going to have either converging or diverging wells. One example would be if you've got 5 wells in a lease where you think the wells are parallel to each other. You may have a spacing of 150, 200 feet. You've drilled the wells with MWD and you've placed them exactly 150 feet apart. But in reality, those wells are not 150 feet apart because of the errors on the MWD system, the lower accuracy of these systems. Say well 1 is straight. Well 2 is actually heading a little bit closer to well 1. Well 3 is actually diverging from well 2. You can either have frac hits, or you end up with an area where you're going to leave hydrocarbons in place and your frac's actually not even going to reach that area of hydrocarbons. We've got some examples of that where you can have frac hits, and you know yourself from your experience that you could end up losing the production from long sections of the well where they're now communicating between the fracs. And that's caused by either overzealous fracking or poor wellbore placement.
I would think Gyrodata probably has a lot of data themselves on how many fracs out there do have some of these issues, right? It would probably be a selling point to say, hey, you know, we could have saved you some trouble out there.
Unfortunately, a lot of companies deny they've got frac problems.
Oh, do they?
Yeah, they do, yeah.
I think most people think it's easier to know where your drill is going underground, but one of the stories I was told was that you had a case in Russia where one of your surveys revealed that they had drilled over a kilometer from where they thought they were.
That's a pretty extreme example, but it does happen. And what would happen in these situations is they'd use an MWD tool. And maybe the MWD tool was at a higher latitude, which basically makes the errors even bigger, yeah, because you've got less magnetic field the higher the latitude. What happened in that situation is that they ran one tool for the entire well, and that one tool had a very significant gross error. As an example, they thought they were drilling at a direction of 15, where in fact it was 45. You drill a 15 to 20,000 foot well, and you're that far off in direction, you're going to be hundreds and hundreds of feet or meters away from where you expect them to be. There's less dramatic examples of that, but I know in my 32 years history with Gyrodata, I've seen wells as much as 50 to 60 degrees in direction wrong, but have caused massive displacement errors. And if you're in an infill drilling campaign or you're in an offshore environment, that could lead to a blowout and unfortunately people dying because you're going to hit a well that you didn't think you were anywhere nearby.
Right. And it was explained to me that you were able to show operators who've drilled earlier what's wrong with their wells through information from your surveys. For instance, what appears to be a smooth slope is actually pretty craggy when you add more data points in between.
Yeah, most MWD tools in drilling and surveying sequence is one stand length, and the stand length is between 92 and 98 feet. That's the typical survey frequency. It's a well-known Stockhausen effect where you drill with a motor, you're building and dropping. It's more like a sine wave as you're drilling. And when you take the measurements, it looks really smooth, but you've got this high tortuosity or high dog legs, as people mention, in between data points. One thing that we have from our technology is able to post-process data from last year or years before of processing the data and showing the clients at 1 foot intervals or even smaller the exact delineation of the well, so we can show them exactly what that sine wave looks like. And that's got huge implications for them. It could be they couldn't get casing down, they can't get a perforating string down, they've got premature wear, they can't get an ESP down. And typically it'll be after they've had a problem, they'll come to us and say, look, this well looks straight, what's wrong with it? And we'll post-process the data and we'll show it's like a ski slalom, it's not straight.
Yeah, it's like a shark tooth.
Exactly, yeah.
Can you do remedial drilling, especially when some of these wells have been drilled or kind of jagged?
It's not something that we offer. We divested our drilling business earlier last year, but most companies wouldn't try and fix the problems once they've had casing run. Once you have casing in the ground, it'd be tremendously expensive to try and cut that and pull it back to surface. What some companies would do is they would try and pull back and ream the well to try and ream away these jagged edges, as you talk about, the sine waveforms. So they'll go up and down and they'll not re-drill the section, but they'll ream it. And then that will hopefully take away a lot of the craggy edges or the jagged edges on the well.
Alan, I spent a lot of time in the industry, and I was there in 2014 when oil prices dropped, and a lot of people lost their jobs at that time, and I think they also had a rough time very recently. But from what I can tell, Gyrodata has survived at least half a dozen booms and busts. They've been around since the 80s. What do you think has been the secret for a company like yours?
That's a tough one. I think for all companies, it's to learn from your previous mistakes, so how you dealt with the previous downturn. I've been in the industry 32 years now. I remember in the mid-1980s, the recession in the oil field at that time and how impactful it was in Aberdeen and Scotland to not only me, but my family. And then since then, there's been a multitude of boom busts. Yeah. For us, with myself and my colleagues and executive team, was really to learn the lessons from what worked last time and what didn't work, and to do things in a timely manner where you don't burn cash. The lesson we learned from 2015 or after the Vienna OPEC meeting, I think it was November 30th, 2014, was that we were slow to react. We thought it was going to be a V-type recession like it was during the financial crisis, and it was not. Yeah. And I still think we're still in that recession from 2015. That was probably the first time the dynamics changed, where the US became the swing producer. It was no longer Saudi Arabia or OPEC. And once you understood that, you realized that what really is a V-type recession and what is not. So the recent pandemic and the double black swan event was a V-type recession. It wasn't based on true supply and demand. It was really just based on the entire free fall of demand because of the COVID restrictions globally. But when the pandemic ends, it'll bounce back pretty quickly, and then the markets will balance again. 2015, we learned a lesson from that. And one thing that we did really quickly last year was to watch our cash flow and immediately cut costs. And it's not just immediately cutting people. Yes, that's part of it. And it's a really horrible part of my job, letting good people go to save money for the company. But you understand that when there's not enough work, you need to do that. But also our vendors, our supply chain, looking at technology to reduce cost. And that's something we've done tremendously well over the last year. Uncrewing operations on the rig. How do we improve efficiencies? And we did that really, really quickly. And really by Q3 last year, we were stable again. And that's something that we learned our lesson from 2015 is react quickly with a very organized manner of how you do it. And protect cash was our goal last year.
Yeah, and I appreciate anyone who doesn't do that standard MBA move of, times are tough, let's just cut head. There's a lot of other ways you can lean out at times.
There's always, you look at any organization, there's ways of improving efficiencies without touching the human side of it. Unfortunately, we did have to retrench a lot of people. We just couldn't afford to keep the payroll as it was when the market was double in size. But for us, it wasn't just that. It was exiting some real estate, selling some properties where we shifted from having capital tied up in real estate to selling it. Just different ways of making sure we had liquidity.
Were there any businesses when you had to pull back in the past where you're like, times are tough, this is one of the darlings we had to kill? Was there a service that maybe you would have liked to see Gyrodata return to at some point?
Not really. Gyrodata has gone through a bit of a transformation in the last year. We divested 2 product lines that weren't core business, and we're now back to the core business that we had in 2009 before we entered those markets. And now with our new technologies, we're extremely focused on developing that product line, which is a gyro product line, which is what obviously the proper noun is, Gyrodata. Yeah. For us is to focus all the incredible people all around the world that we have working for us, really focus on that product line and grow it. And we have some amazing technology that will enable that.
Switching gears a little bit, you also operate in the mining sectors. This is EnergyCast, so how have you helped those energy sectors?
We do quite a lot of that in Canada and Africa and South America. They're still below ground, so they still can't use GPS signals. So there's still a need for gyroscopic instruments to help them navigate the mine shafts or the drilling. And mining is pretty interesting, where sometimes if it's methane extraction, they have to drill 3 or 4 wells. One is an exhaust well and 2 or 3 others for pumping. They require the precision of gyros to do that. It's quite a niche market for us, but it's pretty interesting as well that mining is completely different than oil and gas, that's for sure. It's pretty slow paced compared to an oil rig.
You mentioned mine shafts. I'd be remiss if I didn't ask you about this. Gyrodata was also in the news because you helped during the 2010 Chilean mining incident. Tell us a little bit about that, and were you specifically involved in that?
I wasn't specifically, but my colleagues involved at the time. I was based in Kuala Lumpur when that happened, but it was something we're incredibly proud of, that we could help save lives. What we provided was really the precision of the gyro to help drill a shaft that could rescue the miners, and then we used the gyroscopic precision to ensure that we intercepted the shaft very, very accurately. It's something that's great to be able to use our technology for such a great cause.
And Alan, from what I can tell, you've been with Gyrodata your whole career and started a few years after they were founded. So what have been some of the biggest innovations in that time that you've seen?
Well, I've been 32 years with Gyrodata. I started my career with a company in Aberdeen in Scotland. And I think we've remained focused to our core business, which was gyroscopes. I think the fundamental, impactful innovation is when we developed the MXY gyro. The MXY gyro was a gyro which allowed us to have a spinning mass gyro used in a rough drilling environment and maintain accuracy. And that really changed our fortunes for gyro hole drilling. We ended up with two new products from that, GWD-70 and GWD-90. And that technology really allowed us to develop and learn high-angle gyro surveying at horizontal, which is very niche and extremely complicated. And then that enabled us 2 to 3 years ago to launch our Spear technology, including our latest solid-state Quest. So for me, the Spear technology launch is huge in the industry. It's groundbreaking. It's going to completely transform in the future the way we drill wells.
Do you think that solid-state gyroscope will be useful in other applications besides drilling?
Yes, we're looking at different opportunities in pipelines, in mining, and other energy sectors. One of the great things about this technology is it allows us to reduce our carbon footprint. The technology reduces the number of trips so we can uncrew operations, so we don't need a vehicle to get to the check-in. We don't have to fly to a remote country. We don't need a helicopter to go offshore. That's one thing for us which is really impactful of our ESG policy of how do we reduce our carbon emissions as a company.
That's great. I'm going to finish with a lightning round of your thoughts on different energy technologies, starting with natural gas.
Natural gas has got the potential to be a clean energy. I think a lot of the factories and a lot of the power plants that are using other hydrocarbons, I would like to see natural gas being used in them more, as well as hybrid vehicles. We just need to work out ways to make sure that when we produce the gas, we don't flare it.
Crude oil.
We're going to need it for a long time.
Nuclear.
If it wasn't for the bad rep, I think nuclear is a good, clean fuel. It's just when something goes wrong, it goes wrong massively. Yes, nuclear has got potential, but not with the current fission technology. It needs to be something which is lower risk.
Coal, and I'll also add coal with carbon capture.
Coal's a bad word for me. Open strip mining. Somebody says coal, I think of strip mining and the damage it does, as well as the putrid black smoke when it's burnt. For me, coal has got a 2 thumbs down. It's a hydrocarbon that we should use as last resort.
Wind.
Absolute eyesore off the coast of Scotland and England. We've got this beautiful coastline, and all you can see is thousands and thousands of windmills. So I question the cost to build those windmills to dispose of them. But there's definitely potential there, but I think it's ruining a lot of beautiful landscapes.
Solar.
Works in the Middle East. I'm not too sure where else that's actually going to work. And the cost of the panels, I see some people with Teslas, they've got a solar panel. I'd love to see how long it's going to take them to get their money back on that investment. I think it's a feel-good technology, but unless you've got the massive solar farms like they have in the Middle East, it's actually a question of whether or not it's actually beneficial to the environment.
Biofuels.
It's not something I'm very familiar with. I know sometimes in Europe, when I look at the diesels, it says it's biofuels, but again, I see that as a niche product. I think longer term, it'll fade.
Hydroelectric.
Been around for a while, Hoover Dam and a lot of the places in the world, but the problems with hydroelectric is the massive capital investment it takes to build those. You've also got a pretty significant environmental impact when you flood the other side of the dams. I think a hydroelectric is going to be a dying form of power in the future.
Geothermal.
If you've got it in your country, I think it's going to be a booming sector, whether it's in Holland or Indonesia or elsewhere. I think geothermal is a good, clean way of producing electricity. I think that's going to be a boom market in certain countries of the world moving forward.
Electric vehicles.
They're lovely to drive, but when they cost $120,000 for the top-of-the-line model, it's more of a fashion accessory and then something that's improving the environment. You still need electricity to charge those batteries, and where's that electricity coming from? Overall, the nitrogen dioxide emissions and carbon dioxide emissions will be, for inner cities especially, it will be shifting the pollution out with inner cities. So I think electric vehicles will be by far the majority of vehicles on the road in decades to come. Is a clean source of vehicles? I'm not too sure, but it definitely shifts the pollution out of inner cities, especially nitrogen dioxide with diesels, etc. It shifts the pollution out with cities.
Energy efficiency.
I look at a lot, and there's some simple things you can do in your home just to reduce your air conditioning bill as well as your heating bill. And then the same with using LEDs and timers, etc. I think there's a lot we can do there to be more efficient on our consumption of energy.
And finally, fusion power.
My brother worked for British Nuclear Fuel, so I'm a little bit biased on this one. I think fusion power has got massive future potential for our race. I really do. If we can harness its power and do it in a safe manner, I think it could be the fuel of the future if we can pull it off.
All right, Alan Bernard, Gyrodata, thank you so much for your time.
Thank you very much.
That was Alan Bernard, Senior Vice President of Gyrodata, a drilling service and technology provider based in Houston. I want to thank Alan for his time, as well as Stephen Forrester at Gyrodata for reaching out and setting this up. You can find plenty of pictures for this episode on energy-cast.com, as well as on Instagram and Parler at Host Energy and Twitter at Host Energy Cast. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 107. Be sure to join us next week when we explore a completely new technology for making hydrogen. Until then, I'm Jay Downhauer. We'll see you next time.